Welcome to the AI Research Roundup. I'm Alex. Today, we're looking at a paper from the Hugging Face trending list, published on February 26, 2026, about 5 days ago. It introduces the first comprehensive benchmark and multi-agent framework designed to catch hallucinated citations in scientific writing, achieving over 97% accuracy on both generated and real-world test sets. The paper is titled CiteAudit. You cited it, but did you read it? A benchmark for verifying scientific references in the large language model era. And as we'll see later, the results highlight just how fragile current automated tools are compared to this new approach. Well, Figure 1 maps out the motivation behind this project. The top panel highlights that accurate citations are fundamental for protecting authorship and advancing technology. However, Panel B illustrates the rising challenge. As large language models generate fake references, existing verification tools often fail to catch them. Panel C then pinpoints the specific gaps, noting that prior work relied on synthetic data, whereas this benchmark introduces real-world data collected in the wild for a unified evaluation. Well, Figure 1 established the gap in existing benchmarks. Now, Figure 2 breaks down the taxonomy of citation hallucinations used to create the synthetic dataset. The top panel focuses on title errors, ranging from subtle paraphrasing to completely fabricated titles. The middle section illustrates author errors, where names are added, deleted, or perturbed to confuse attribution. Finally, the bottom panel details meta-errors, like mismatched venues or incorrect dates, which ensures the benchmark covers the full spectrum of potential mistakes. So while Figure 2 explained the error types, Table 1 breaks down the actual scale of the benchmark. The first row details the generated test set, comprising over 6,000 entries total, with 2,500 fake citations synthesized by models like GPT and Claude Sonnet. The second row presents the real-world test set, sourced from actual repositories like Google Scholar and Open Review. Although this subset has fewer fake examples, just 467, it is vital because it captures the naturally occurring hallucinations found in authentic scientific drafts. Alright, having established the dataset, Figure 3 maps out the complete CiteAudit workflow. It operates as a multi-agent pipeline governed by the standard operating procedure listed on the left. First, the extractor agent converts raw PDF text into structured metadata. Then, the memory agent checks a local cache for a quick match. If that fails, the web search agent triggers an external lookup. And finally, the judge and scholar agents validate the evidence to detect any hallucinations. So, with the pipeline defined in Figure 3, Table 3 now reports the performance on the generated test set. The results are striking. The proposed model, listed at the bottom, achieves an F1 score of nearly 0.97 and a perfect recall of 1.0, catching every single hallucinated citation. By comparison, GPT 5.2 takes nearly 50 seconds to process a batch that this model handles in just over 2. Furthermore, the cost columns reveal that while commercial APIs are expensive, this framework operates at zero direct cost, ensuring scalability. Well, having seen the generated results, Table 4 shifts focus to the real-world test set, where the performance gap becomes even more apparent. Looking at the bottom row, the proposed framework maintains a perfect recall of 1.0 and an F1 score of 0.90, drastically outperforming general models like Gemini 3 Pro and Claude Sonnet. The confusion matrix reveals why. The system identified all 467 hallucinated citations with 0 false negatives. In contrast, the commercial models listed above missed over 100 fake references each, proving they are too unreliable for rigorous scientific auditing. Wrapping up, CiteAudit provides a crucial safeguard for scientific integrity, proving that specialized multi-agent systems can effectively detect hallucinated citations where general models fail. As AI-generated content grows, tools like this will be essential for reviewers and publishers to maintain trust in the scholarly record. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.